Okay, let's talk volumes. So we're still scaling solids. We've just been talking about area for a few lessons. Let's bring it into volumes for a few lessons. Find the volume of each cube mentally. Length times width times height. Length times width times height. That's a cubed. Length times width times height. Length times width times height. Okay. How do surface area and volume change with scaling? Use unit cubes to build cubes that result from dilating the unit cube by each scale factor shown in the table. Then complete the table with the surface area and volume of each dilated cube. A unit cube is just a 1 by 1 by 1. So 1, 1, and 1 is 1 unit. If I have a scale factor of 1, the surface area in square units would be, I've got 1, 2, 3, 4, 5, 6 faces, so the surface area is 6 times the area of one face. Okay, so the area of one face is 1, so the surface area is going to be 6, and I'm in square units, so units squared. If I have a scale factor of 2, that now means that I have 2 cubes up, 2 cubes back, and 2 cubes up and down. So my surface area is going to be not just one of these, but more. Actually, I think there's an applet. Let me go find it. This will make much better sense. So we did a scale factor of 2, so I want this to be 2 blocks long, 2 blocks wide, and 2 blocks high. So what is our surface area? Well, that's all the surfaces. There's 6 of them. 6 times each face is a 2 by 2. So the surface area is 24. So 2 by 2, 2 by 2, and do that 6 times. All right, so let's go over here. I still want you guys to take notes. So we did scale factor of 2. Our surface area is going to be 24. And I think we can see a pattern. Well, let's do this. Hold on. So we're 6. I think we might be able to see a pattern. Can you guys see that before? All right, so now we're doing a scale factor of 3. So we're 3. Now surface area, so if I look at each surface, I have 3 times 3, so that's 9. And there's 6 of those. So the surface area is 54. Then a scale factor of 4. So our surface area is 1, 2, 3, 4, 1, 2, 3, 4. So each face is 16, and there's 6 of those faces. Okay, now let's talk volume. Our original scale factor of 1 has a volume of 1. Scale factor of 2, if we go over, it'll take us a second. What's our volume? Oh, no. Sorry. So our volume is 2 by 2 by 2. 2 by 2 by 2 is 8. Okay, scale factor of 3. Our volume is 3 times 3 times 3, which is 27. Yep. And then a scale factor of 4. What is our volume? 4 times 4 times 4, which is 64. Okay, do we see anything? Do we see any patterns? I love patterns. This is our scale factor, squared. We'll call it K squared. Okay, it's surface area, so it's 6 times our scale factor squared. Okay, because we have a unit cube. So that's 2 squared, 3 squared, 4 squared. So it's 6 times that. Now the volume is our scale factor cubed. 1 cubed, 2 cubed, 3 cubed, 4 cubed. All right? So if we write an expression for the surface area of the dilated cube, it's 6 times K squared. Write an expression for the volume of the dilated cube, it's K cubed. I guess it would be the original area. For that, it's 1. I don't like that. So the area of the image times 6, because there's 6 faces, times K squared. And here we would have the volume of the image times our scale factor cubed. Compare and contrast the expressions for surface area and the expression for volume. Okay, 1 second. So compare and contrast the expression for surface area and the expression for volume. If I just go back over here, our surface area expression is 6 times our scale factor squared, and our volume expression is our scale factor cubed. I can compare and contrast them. Like the area, we always have units squared because it's length times width, which means we're going to scale each the length and the width, which gives us our scale factor squared. And then for volume is always units cubed because there's 3 dimensions, length times width times height, which when I scale something I have to scale each dimension, which gives me my K cubed. Okay? Cool. Scaling all solids, Claire says we know that if we dilate a cube by a factor of K, the cube's volume is multiplied by K cubed. It seems like that must apply to all solids, but I'm not sure how to prove it. Alina says, earlier in the unit we showed how we can cover any 2-dimensional shape with rectangles. Do you remember the blob? So the property that area changes by K squared. When we dilate a figure by K, So the property that area changes by K squared when we dilate a figure by K applies to all shapes, not just rectangles. Can we do something similar here? Use Alina's line of reasoning to argue that for any solid, if it's dilated by a factor of K, the volume is multiplied by K cubed. Okay, in the previous blob, it was just 2 dimensions, length and width. But here we're talking volume, so our blob would have to be 3 dimensions, length, width, and height. And we can fill that blob with cubes. Okay, an infinite number of cubes. And if we scaled those cubes, we would be scaling them the length, the width, and the height of the cubes, which would be scale factor of each dimension, which would be K cubed. Okay, suppose a triangular prism has a surface area of 84 square centimeters and a volume of 36 cubic centimeters, So we have triangular prism, which is basically this, but 3-dimensional. Surface area is 84 centimeters cubed and a volume of 36 centimeters cubed. The prism is dilated by a scale factor of 4. Calculate the surface area and the volume of the dilated prism. Well, we're just going to do by 4 squared and by 4 cubed. (1,344). Sorry, this would be squared because it's a surface area. And this would be 36 times 4 cubed. Okay, that's it. We're not doing the cool down. Nice work.